Greetings everyone, welcome back to our YouTube channel, Combi Universe. So today we are going to be seeing something quite interesting, that is electric charges. As there is a second part, question 2. My colleague got to do already question 1. So let's read the question together to get started and understand it once and for all. So how many electrons will have to be removed from a penny to leave it with a charge of 1.0 exponent negative 7? So this penile is actually having a certain number of electrons and the charge is different originally. So the question right now is asking you that how many electrons required to be removed before the charge get to be 1.0 exponent negative 7. We get to know that the charge in an atom generally, or yeah, a penile for this case, is going to be the number of electrons times the electronic charge. So to get a ratio or the value, the number of electrons that need to be removed from that penile to obtain this, you need to fractionate the total charge required from the penile to the electronic charge. This one is somehow straightforward and easy to the point. So let's get right now to see what is the B part talking of. To what fraction of the electrons in the penile does this correspond? A penile has a mass of 3.11 gram. Assume it is made entirely of copper. So for this B part, we are required to bring out a fraction of the number of electrons in which we calculated actually when the charge was 1.0 exponent negative 7 coulomb to the number of electrons when the penile is natural occurred. That's as in the number of electrons when it just occurred in nature. So let's proceed with it. Okay, so like I said, let's proceed. So how do we get right now to obtain the number of electron in the penile when it is of natural occurrence? That is from the concept of chemistry, with having in mind that we can easily get the number of atoms being equals to the number of moles times the Avogadro's constant, which is 6.02 exponent 23. But getting right now the number of moles, we get it from 3.11 gram divided by the molar mass. So let's get to see the different. Before even getting to see the different formulas, how will this help us? Let's just proceed into seeing the different formulas. Like I said, to get the number of moles in copper, that is mass divided by molar mass, and the mass was provided in the question. And generally, the molar mass of copper is considered to be approximately 64, though here we took the necessary precision, that is at 63.54. So once you have the number of moles in the copper, like we said, we make use of number of atoms, which is equals to number of moles times Avogadro constant. That is the value. So from here, how do you actually obtain right now number of electrons from the number of atoms? That is a very complex question, because if in copper we have this number of atoms, and in each atom of a copper, if you look at the structure of an atom, we do have protons, neutrons, and electrons here on the shell, where the number of protons and electrons are usually considered to be correlated. So for this question, since we are dealing with entirely copper, that's pure copper, the number of protons in copper is given to be 29 protons. So one atom of copper do have 29 protons. And here we do have how many atoms? 2.95 times 10 to the 22 atoms. So how many electrons or how many protons are we going to have from this? Will just be the product of that is that in one atom times the number of atoms in which we have. As easy and straight as that. The main issue here was to relate number of electrons from number of atoms. That gives us 8.55 times 10 to the power 23 electrons, or generally proton, present in the pure copper when naturally occurring. Yeah, that's the penile actually, because the penile is made entirely of copper. So from there we can easily get the fraction now of the number of electrons when the charge was modified to 1.010 to the negative 7, and the number of electrons when the penile was naturally occurred, that is this divided by this, and we do have 7.3 exponent negative 7 exponent negative 13. So hope all the points were clarified. For any doubts, put in the comment section. We shall attend to you brief and shortly. Thanks for your time.